When we look at a map of the world, we see massive, flat blocks of blue. It gives us the illusion that the ocean is mostly a surface boundary, but beneath those waves is a staggering vertical volume that defies human scale. To put this into perspective, if you were to shave off all of the land from every continent and island and dump it into the deepest trenches to make a perfectly smooth sphere, the entire Earth would be encased in a global ocean 2 miles deep. This chart compares some familiar terrestrial objects to help us map our descent. We start with a single dot representing the size of an average human. Next to it, a slightly larger dot shows the size of an elephant. Pulling out further, we compare those dots to the largest ship ever built, the massive Knock Nevis supertanker. 3/4 of our planet is covered in water, holding volumes so massive that the immense pressure and hostile physics keep 95% of the ocean floor completely hidden from us. Let's trace exactly what happens as we go down. Heading 40 meters below the surface, we hit the maximum depth allowed for recreational scuba diving. Dropping to 93 meters, we find the resting place of the Lusitania. The ship itself is 240 meters long. It sank in water shallower than its total length. If resting vertically on its stern, half the vessel would be sticking out into the air. Human biological limits max out shortly after. At 214 meters, Herbert Nitsch set the free diving world record on a single breath. Down at 332 meters, we reach the absolute scuba diving world record achieved by Ahmed Gabber. If Gabber swam another 111 meters, he would reach the tip of the Empire State Building, assuming the entire skyscraper was placed underwater. At 500 meters, we hit a dual boundary. This is the maximum dive limit for the blue whale, the largest animal on Earth, and the U.S. Seawolf-class nuclear submarine, representing the edge of standard military engineering. Descending to 830 meters places us at the base of an inverted Burj Khalifa, the tallest freestanding building in the world. Every towering architectural achievement and advanced military vessel we construct barely penetrates the uppermost layer of the ocean. Crossing the 1,000-meter mark, we drop into permanent darkness. Sunlight cannot penetrate beyond this point. This depth also introduces extreme physics. The water pressure here roughly equals standing on the surface of Venus. The leatherback sea turtle manages to dive to a depth of 1,280 meters. Push past that to 1,828 meters, and we've reached an underwater equivalent of the very bottom of the Grand Canyon. At 2,000 meters, survival requires extreme biological adaptation. Creatures like the black dragonfish hunt here. Its stomach lining is entirely opaque to prevent the glowing bioluminescence of its prey from shining through its body and exposing it in the pitch black. Dropping further to 2,250 meters, we enter an active combat zone. Sperm whales dive to this depth to hunt colossal squid. These squids grow to 14 meters long and weigh 750 kilograms. They fight back with razor-sharp sickles embedded in the middle of their tentacles. Continuing the descent into freezing isolation, we arrive at 3,800 meters, where the shattered remains of the RMS Titanic lie resting in the mud. The loss of sunlight creates an environment where only highly specialized organisms and the silent relics of human history exist. The abyssal zone starts at 4,000 meters. The pressure here surges toward an astonishing 11,000 pounds per square inch. It's equivalent to a polar bear standing on a quarter, scales up to an elephant balancing on a postage stamp, and finally 50 Boeing 747s pressing down on a single person. We pass the wreckage of the World War II battleship Bismarck at 4,791 meters, before crossing the 6,000-meter line. This is the beginning of the Hadal Zone, named after the underworld, Hades. To survive here requires specialized machinery. The famous DSV Alvin, the research submersible that helped locate the Titanic, hits its maximum limit at 6,500 meters. Plunge down to 8,848 meters, and we've reached a depth exactly equal to the height of Mount Everest, assuming you ripped it out of the Himalayas and dropped it in upside down. In 2012, filmmaker James Cameron piloted the Deep-Sea Challenger down to 10,898 meters, pushing the limits of modern materials. Yet the deepest point reached by humans actually happened over 50 years earlier in 1960. Down Walsh and Jacques Picard spent 5 hours descending in the Trieste bathyscaphe, eventually touching down at 10,916 meters. Reaching these extreme-specific coordinates means building a craft capable of surviving conditions that instantly destroy terrestrial biology. The next time you take a commercial flight, look out the window at cruising altitude, which averages about 10,972 meters. Now, physically invert that distance downward, plunging through miles of black, freezing water. That distance brings us to 10,994 meters, the floor of the Challenger Deep, the absolute lowest point on our known map. But our current map still has massive gaps. Trenches stretching thousands of meters deep easily hide in this total darkness. The 10,732-meter Sirena Deep, the second lowest point on Earth, wasn't even discovered until 1997. This map shows our current progress. We have accurately surveyed roughly 5% of the ocean floor. The remaining 95% is a complete blank. The vertical ocean is an unexplored frontier of pressure and total darkness, concealing deep geographic mysteries just miles below our feet.